Hello class, in this video I'll be showing you another example on how to solve a system of linear inequalities. Let's begin. Okay, so I've already gone ahead and labeled all of our lines, and you may have noticed that I labeled one of the entries as 2 lines. I'm going to show you why in a moment. Okay, so I'm going to go ahead and solve the top equation, or the first line, for y. And I'm going to do that by subtracting 3x from both sides and then dividing by 4. So if y is greater than -3/4 x plus 3. So the slope is -3/4. The y-intercept is 0, 3. The boundary line in this case is going to be a dashed line. And that is because y is strictly greater than the expression to the right, meaning that the boundary line is not part of the solution. And the feasible region is going to be above the line. So I'm going to go ahead and graph all that now. So starting at 0, 3, the slope says to go down 3 to the right 4. So down 3 to the right 4, down 3 to the right 4. You can also go up 3 to the left 4, and then up 3 to the left 4. And this will be a dashed line, because the boundary line is not part of the solution. And the feasible region is going to be above this line. Okay, on to line number 2. We're going to start by subtracting 2x from both sides. And then we're going to divide all 3 terms by -3. And that is supposed to be a y right there. And now, since we're dividing all of the terms by a negative number, we're going to reverse the inequality. So the slope is 2/3. The y-intercept is 0, -2. The boundary line in this case is going to be part of the solution because we have equality. So it's going to be a solid boundary line. And the feasible region is going to be above the boundary line. So the feasible region So I'm going to go ahead and graph that now. So starting at 0, -2, the slope says to go up 2 to the right 3, up 2 to the right 3, and so forth. You can also go down 2 and to the left 3. And this is a solid boundary line. All right, the feasible region for this line is also above it, like such. So it looks like our solution region, or our feasible region, is going to be somewhere in here. So on to lines 3 and 4. So I'm going to break this double inequality into 2. The first one is y is greater than 0. So that is going to be a dashed line along the x-axis. So this is a dashed boundary line. And it's going to be along the x-axis. and the feasible region is going to be above. The second line in this double inequality is y is less than or equal to 2. And that's going to be a solid line. And the solution is below. So I'm going to place a horizontal line like such that passes through the point 0, 2. And this is the borderline y is equal to 2. And we're going to shade below this line and above this line. And finally, we have x is greater than or equal to 0. And that is going to be a vertical line that's solid, and that's going to go along the y-axis. And we want values that are greater than or equal to 0, so that's going to be to the right of that line. So it looks like our feasible region is going to be this small little triangle right here. And the corners are going to be, well, actually there's only one corner, and it's going to be right here, because the corner has to be part of the feasible region. This intersection here and this intersection here are not part of the feasible region. So in fact, there's only one corner. And again, the solution to this system of linear inequalities are going to be all the ordered pairs within that region right there. And we can conclude that the feasible region is bounded.